August 30th, 1992. At the University of Hawaii's Mauna Kea Observatory, perched atop a dormant volcano nearly 4,200 meters above sea level, astronomers David Jewett and Jane Liu are staring intently at a faint smudge of light on their telescope's detector, an object roughly 42 astronomical units from the Sun, far beyond the orbit of Neptune, in a region of space most astronomers at the time assumed was essentially empty. They name it 1992 QB1. It is the first object ever confirmed in a distant region that had been theorized decades earlier, but never actually observed, the Kuiper Belt. Jewett and Liu had spent 5 long years searching for exactly this. Patiently, methodically scanning the outer solar system night after night, convinced that Pluto, discovered back in 1930, simply couldn't be alone out there. They were right. In the decades since that August night, astronomers have cataloged more than 3,000 additional objects in the same distant region, and NASA spacecraft have flown close enough to photograph a handful of them directly, in extraordinary detail. What they've found out there is stranger, and stranger still, than almost anyone expected. A graveyard of misshapen worlds, contact binaries, objects with impossible colors, ring systems that shouldn't be stable, and structures that shouldn't be able to exist at all, this far from the warmth of the Sun. This is everything we've learned about the bizarre worlds hiding beyond Pluto. The idea that something might lie beyond Neptune and Pluto wasn't new when Jewett and Liu began their search in the late 1980s. As early as the 1940s and 1950s, astronomers, including Kenneth Edgeworth and separately Gerard Kuiper, had speculated that the outer solar system might contain a broad disk of leftover icy debris, material left over from the formation of the solar system 4.6 billion years ago, too far from the Sun and too thinly spread out to ever coalesce into a full-sized planet of its own. For decades, this remained pure theoretical speculation, since no telescope of the era possessed anywhere near the sensitivity required to actually detect objects that small and that faint, sitting billions of kilometers away, reflecting only the barest trace of sunlight, HT back toward Earth. Pluto itself, discovered by a young American astronomer named Clyde Tombaugh in 1930 after a painstaking years-long photographic search, was for a long time treated as a strange cosmic outlier. The solar system's supposed 9th planet, oddly small, oddly icy, and orbiting on a strangely tilted and elongated path compared to the 8 planets orbiting closer in toward the Sun. Jewett and Liu's 1992 discovery changed everything almost overnight. Once astronomers finally knew roughly where and precisely how to look, the floodgates opened rapidly. Within just a few years, dozens of additional Kuiper Belt objects were cataloged in quick succession, and it quickly became unmistakably clear that Pluto wasn't some lonely, isolated oddball after all. It was simply the largest, brightest, and easiest to spot member of an entire population of icy bodies stretching from roughly 30 astronomical units out to 50 astronomical units from the Sun, and quite likely well beyond that range too. This growing realization directly led, in 2006, to the International Astronomical Union's now famous and still controversial decision to formally reclassify Pluto as a dwarf planet rather than a full planet. Not because Pluto itself had changed in any way, but because astronomers finally understood it belonged to a much larger family of broadly similar objects, rather than standing apart as a unique, solitary 9th planet. Today, the Kuiper Belt is understood by planetary scientists to be a vast donut-shaped region of icy bodies, comets, and dwarf planets, estimated to contain hundreds of thousands of individual objects, larger than 100 kilometers across, and likely trillions of smaller icy fragments beyond that, a region roughly 20 times as wide and possibly anywhere from 20 to 200 times as massive as the more familiar asteroid belt orbiting between Mars and Jupiter. Scientists have also learned that the Kuiper Belt isn't one uniform populatio, N of objects, but actually splits into several distinct dynamical families based purely on the shape and behavior of each object's orbit. The classical Kuiper Belt objects follow calm, only mildly elliptical orbits, largely undisturbed by Neptune's gravity. Resonant objects, including P, Pluto itself, are locked into precise mathematical relationships with Neptune's own orbit. Pluto, for instance, completes exactly 2 orbits around the Sun for every 3 orbits Neptune completes, a relationship that has protected Pluto from ever colliding with Neptune despite their orbits crossing on per. And scattered disk objects, including Sedna and Eris, follow much more extreme, elongated, and often steeply tilted orbits, having likely been gravitationally flung outward by close past encounters with Neptune earlier in the solar system's chaotic history. The first genuinely close, detailed look at a large Kuiper Belt object came on July 14, 2015, when NASA's New Horizons spacecraft, after a 9.5-year journey spanning the entire solar system, screamed past Pluto at over 13 kilometers per second, capturing images with a level of resolution no body had ever come close to achieving for this distant, previously blurry world. What New Horizons found overturned decades of confident assumptions almost immediately. Scientists had generally expected a dead, uniformly cratered ice ball, roughly similar in spirit to Earth's own ancient geologically inactive moon. Instead, Pluto turned out to be surprisingly, genuinely geologically active, or at the very least, to have been significantly active in the relatively recent geological past. Its single most famous feature, a massive, smooth, heart-shaped region now formally known as Tombaugh Regio, in Eris, honor of Pluto's discoverer, contains a vast plain called Sputnik Planitia, an enormous basin filled with nitrogen ice, broken up into irregular polygon-shaped cells roughly 20 to 30 kilometers across, clear evidence of slow-motion convection currents actively churning the nitrogen ice from underneath, in much the same visual way that a lava lamp slowly circulates its wax in gentle, rising blobs. Pluto also turned out to possess genuine mountains made of solid water ice, some reaching heights comparable to sections of Earth's own Rocky Mountains, rising dramatically out of the surrounding nitrogen ice plains, like icebergs floating in a frozen sea. New Hori. Zons detected clear evidence of a thin, hazy nitrogen atmosphere, extending in multiple distinct layers far higher above the surface than scientists had originally expected, along with possible cryovolcanoes scattered across the surface. Ice volcanoes that, rather than erupting molten rock the way ordinary volcanoes on Earth do, may instead erupt slushy mixtures of water ice, ammonia, and other frozen compounds from somewhere deep below Pluto's crust. One particularly compelling candidate cryovolcano, informally named Wright Mons, spans roughly 150 kilometers across at its base and rises somewhere between 4 and 5 kilometers high, complete with a deep depression at its summit strongly resembling a genuine volcanic caldera back on Earth. Perhaps strangest of all, given just how cold and impossibly distant Pluto is from the Sun, scientists eventually found strong, compelling evidence suggesting a genuine liquid water ocean may exist hidden beneath its icy crust, kept from freezing completely solid by some combination of residual internal heat generated by radioactive decay deep within Pluto's rocky core and the natural antifreeze effect of dissolved ammonia mixed into that subsurface water. This discovery effectively transformed what scientists had once casually dismissed as a small, frozen, entirely inert rock into a serious candidate for one of the solar system's several confirmed or suspected hidden subsurface oceans, joining a growing list that already includes icy moons like Europa, Enceladus, and Ganymede. New Horizons also carried a suite of 7 scientific instruments packed into a piano-sized spacecraft, including a powerful telescopic camera called LORRI, a color and infrared mapping spectrometer called RALPH, and a plasma sensor called SWAP, designed to study how Pluto's thin, escaping atmosphere interacts with the solar wind at such extreme distance from the Sun. Together, these instruments revealed that Pluto continuously loses a small amount of its nitrogen atmosphere to space, a slow but steady process similar in spirit to the atmospheric escape happening on Mars, just occurring at a much colder, more distant world. Orbiting on Pluto is Charon, a moon so unusually large relative to its parent world, roughly half of Pluto's total diameter, that the two bodies are sometimes informally described by Astronomy. Eris is a binary or double dwarf planet system, orbiting around a shared center of mass that actually sits out in open space between the two bodies, rather than being located deep inside Pluto itself. AS is the case with most planet-moon pairings elsewhere in the solar system. New Horizons revealed Charon to be every bit as strange as Pluto itself in its own distinct way. Its single most striking visual feature is a vast, dark, reddish region constant, and traded at its north pole, informally nicknamed Mordor Macula by the mission's science team. Scientists eventually pieced together a genuinely bizarre, almost poetic explanation for its origin. Methane gas, continuously escaping from Pluto's own thin atmosphere, gradually drifts across the empty space separating the two worlds and becomes gravitationally trapped by Charon's comparatively weak gravity at its extremely cold polar region, where it slowly freezes directly onto the moon's surface. Over the following millions of years, continuous exposure to faint ultraviolet radiation arriving from the distant sun chemically transforms that frozen methane into complex reddish organic compounds known as tholins, meaning Charon's distinctive polar cap is, in a very real and literal sense, colored by frost that originally escaped from an entirely different world altogether. Charon also displays an absolutely enormous canyon system carved across its surface, stretching for well over 1,800 kilometers in total length, with some individual sections estimated to plunge as deep as 9 kilometers. Ours below the surrounding terrain, proportionally larger, relative to Charon's small size, than Earth's own famous Grand Canyon, and considered strong evidence that Charon underwent a significant period of internal expansion, sometime earlier in its geological history. Most likely as an internal subsurface ocean GD, gradually froze solid and expanded outward, cracking the moon's brittle icy crust from within as it did so. Beyond Charon, Pluto also hosts 4 much smaller, far more chaotic moons, Nix, Hydra, Kerberos, and Styx, each just a few dozen kilometers across at most, in each tum, bling through space in a genuinely unpredictable, non-uniform rotation, rather than the smooth, locked rotation most moons settle into over time. Scientists believe the combined gravitational influence of Pluto and the unusually large Charon creates a chaotic gravitational environment that prevents these smaller moons from ever settling into a stable, predictable spin, leaving them essentially tumbling end over end indefinitely. If Pluto and Charon fundamentally reset scientific expectations for what large Kuiper Belt objects could actually look like up close, New Horizons' second target reset those expectations again in an entirely different direction. On January 1st, 2019, after a further 4-year journey deeper still into the Kuiper Belt, New Horizons flew directly past a small, previous, obscure object called Arrokoth, located roughly 6.4 billion kilometers from the Sun, making it, at the moment of the flyby, the single most distant object any human spacecraft had ever explored up close in the entire history of space exploration. Arrokoth turned out to look almost nothing like a typical asteroid or comet observed elsewhere in the solar system. It's what scientists call a contact binary. 2 entirely separate lobes, one noticeably flattened and roughly pancake-shaped, the other as smaller and more rounded, gently touching one another at a narrow connecting neck, giving the entire object an unmistakable, almost charming snowman-like silhouette, roughly 36 kilometers long from end to end. Scientists strongly believe the 2 lobes originally formed as entirely Eprit bodies, condensing independently within a slowly rotating cloud of icy material during the earliest days of the solar system, before gradually spiraling closer and closer together under their own weak mutual gravity, eventually merging together gently, almost delicately, at an extremely low relative speed, rather than colliding violently the way most solar system bodies typically do. This unusually gentle merger turns out to be scientifically crucial because it strongly suggests T.S. Arrokoth's overall structure has likely remained largely undisturbed since the solar system's very formation some 4.6 billion years ago, effectively making it one of the most pristine, least altered building blocks of planet formation that human instruments have ever directly examined up close. Its distinctive reddish coloring, broadly similar to Pluto's own more heavily weathered surface regions, comes from that same family of tholins, formed gradually over billions of years of continuous cosmic RE. And ultraviolet exposure, acting slowly on simple frozen compounds like methane and ammonia ice. Arrokoth also displays a scattering of small, mysterious pits and pale, unusually reflective patches spread across its surface, along with a genuinely unexpected reddish collar speck, ithically encircling the narrow neck connecting its 2 lobes, features that scientists back on Earth are, even now, still working carefully to fully explain. Notably, Arrokoth also carries very little evidence of ever having been struck by anything else since its formation. Its surface is remarkably smooth and largely free of impact craters, compared to almost any other solid body examined up close anywhere else in the solar system, suggesting the outer Kuiper Belt is a far emptier, far quieter environment than the inner solar system, where collisions between objects happen far more frequently. Beyond the handful of objects spacecraft have managed to visit directly lies a stranger category of Kuiper Belt residents entirely. Distant scattered disk objects whose observed orbits simply don't make comfortable sense within our current working understanding of the solar system's structure. Sedna, discovered in 2003 by a research team led by astronomer Michael Brown, stands out as perhaps the most famous example of this puzzling category. Its orbit is so genuinely extreme that the object never comes closer to the Sun than roughly 76 astronomical units, and at its most distant point swings outward to nearly 900 astronomical units from the Sun, a single orbit so vast that completing just one full loop takes roughly 11 to 400 years. Sedna's orbit is so remarkably distant and so dramatically elongated that it doesn't fit comfortably within the traditional boundaries of the Kuiper Belt at all, nor is it clearly a confirmed member of the far more distant and still entirely hypothetical Oort-Clo, believed to surround the solar system at even greater distances. Its puzzling existence has fueled ongoing, genuinely serious scientific debate ever since its discovery. including one especially provocative hypothesis that has captured considerable public attention, that Sedna's strange, elongated orbit, along with the similarly strange orbits of several other distant objects discovered in the years since, could potentially be explained by the gravitational influence of an entirely undiscovered, roughly Neptune-sized planet lurking far out in the darkness beyond current telescope reach. The so-called hypothetical Planet 9. Its actual existence, however, remains entirely unconfirmed to this day, and several credible alternative explanations, including the combined gravitational influence of other stars passing relatively close to our solar system during its earliest, most chaotic formative years, also remain seriously considered by researchers studying this ongoing puzzle. Other bizarre objects discovered within the Kuiper Belt continue to add fresh layers to this puzzle. Eris, discovered in 2005, briefly ignited genuine scientific controversy after early measurements suggested it might actually be slightly larger than Pluto itself, a comparison that helped directly trigger the broader debate that eventually led to Pluto's reclassification the following year. Later, more precise measurements determined Eris is a CEO. Two only very slightly smaller than Pluto in diameter, though considerably more massive, made of unusually dense material for an object this far from the Sun. Makemake, another confirmed dwarf planet discovered in 2005, has a surface covered almost entirely in frozen methane and ethane, giving it a distinctly reddish appearance, and was found in 2016 to possess a single, small, unexpectedly dark moon, nicknamed informally as MK2. Quaoar, first discovered back in 2002, was found in 2023 to unexpectedly possess a thin ring system positioned unusually far away from the object itself. So far, in fact, that it sits well outside the theoretical zone, where planetary rings are traditionally expected to remain gravitationally stable over long timescales, directly challenging existing scientific models of exactly how and where rings can reliably form and persist. Haumea, meanwhile, one of the small number of officially recognized dwarf planets located within the Kuiper Belt, spins so rapidly on its own axis, completing one full rotation in under 4 hours, that it has been dramatically stretched by its own powerful rotational forces into a strikingly elongated, egg-like overall shape, unlike any other large body yet identified anywhere else in the solar system. And remarkably, it even possesses its own thin ring system along with two small orbiting moons of its own. Gong, another sizable Kuiper Belt object discovered in 2007, carries an unusually large moon of its own, Shangliu, and displays one of the most strikingly deep red surface colors yet measured anywhere in the solar system. Astronomers have also noticed that Kuiper Belt objects broadly split into two separate color populates. Ions. Some appear distinctly reddish, likely coated heavily in tholins built up over billions of years, while others appear much more neutral gray or bluish in tone, suggesting different surface compositions or different histories of exposure to sunlight and cosmic radiation. What causes this color divide precisely still isn't fully settled and remains an active area of ongoing research. Scientists have also found that binary and multiple object systems appear to be remarkably common throughout the Kuiper Belt, far more so than in the asteroid belt closer to the Sun, likely because objects out here formed and settled into orbit around each other gently in the same slow, low-speed environment that produced Arrokoth's own gentle merger. Taken together, all of these Izari worlds scattered beyond Pluto represent something genuinely invaluable to planetary science. A natural deep freezer, quietly preserving raw material that has remained largely unchanged since the very earliest days of the solar system's formation, over 4.5 billion years ago. Unlike objects located much closer to the Sun, which have spent billions of years being repeatedly heated, partially melted, resurfaced by ongoing volcanic activity, or gradually altered through countless collisions and erosion, many Kuiper Belt objects have instead remained frozen solid and largely undisturbed at the distant outer edge of the solar system for the entire span of that time. Out the extensive geological processes that have long since erased so much of that same early history almost everywhere else in the solar system. Every strange, unexpected feature discovered on Pluto, Charon, Arrokoth, and their smaller, more distant neighbors, the slowly convecting nitrogen ice, the gently Mia, our radiated contact binary structure, the reddish organic tholin compounds, the dramatically unstable elongated shapes, the improbable distant rings, adds yet another crucial piece to the much broader ongoing scientific puzzle of exactly how our own solar system, and by direct extension, countless other planetary systems scattered throughout the galaxy, actually came together and took shape billions of years ago. The Kuiper Belt is also directly connected to something far closer to home than most people realize, many short-period comets that occasionally streak across Earth's night sky, including F-Hydro-SU. Use examples like Comet Halley are believed to originate from the same distant region, gradually nudged inward over millions of years by the gravitational influence of the outer planets, until they finally begin looping through the inner solar system on visible, predictable orbits. In a very real sense, every comet ever watched crossing the sky by ancient civilizations across human history may trace its ultimate origin back to this same frozen, distant belt. ASA's New Horizons spacecraft, having already completed its historic flybys of both Pluto and, later, Arrokoth, continues drifting steadily deeper into the Kuiper Belt to this very day, its scientific instruments still fully active, still quietly gathering valuable data on the distant Remarka. Bly's sparse environment it now continuously travels through. Astronomers back on Earth continue actively searching for a plausible third flyby target somewhere along the spacecraft's ongoing trajectory, while both ground-based observatories and orbiting space telescopes, including the newly operational Vera C. Rubin Observatory, keep discovering fresh new Kuiper Belt objects nearly every single year, each one representing another. Small, frozen fragment of the solar system's earliest history, patiently waiting out there in the cold and the dark for its own eventual chance to be examined up close by human eyes and instruments. Beyond Pluto, it turns out, the solar system doesn't simply fade away quietly into empty, featureless darkness the way many once assumed it must. It keeps going, stranger, colder, and considerably weirder than almost anyone ever expected, all the way out to the very edge of what our current instruments and spacecraft are capable of reaching, and quite possibly well beyond even that. Even with everything New Horizons and ground-based surveys have already revealed, scientists openly admit that the Kuiper Belt remains, in large part, unmapped territory. Current telescope surveys are only sensitive enough to detect the larger, brighter objects in this distant region. Anything smaller than roughly 100 kilometers across, at these staggering distances, remains almost entirely invisible to existing instruments, meaning the full population of the Kuiper Belt is likely many times larger than the roughly 3,000 objects cataloged so far. That's part of why the arrival of next-generation observatories matters so much to this field. The Vera C. Rubin Observatory, having begun full operations in 2025, is expected to survey the entire visible sky repeatedly over the coming decade, and is projected to roughly double or even triple the total number of known Kuiper Belt objects within just its first few years of operation, while also being sensitive enough to catch fainter, more distant scattered disk objects similar to Sedna, potentially finally settling the long-running debate over whether an undiscovered Planet 9 genuinely exists out there or not. There's also renewed interest within the space science community in eventually sending a dedicated orbiter rather than another brief flyby-my. Cian to one of the larger dwarf planets in this region, potentially Pluto itself, allowing scientists to study its slow seasonal changes, its thin atmosphere, and its suspected subsurface ocean over years, rather than the mere handful of hours New Horizons had available during its single unrepeatable pass. No such mission has yet been formally approved or funded, but it remains a frequently discussed priority among planetary scientists mapping out the coming decades of solar system exploration. For now, the picture painted by everything gathered so far, by Jewett and Lou's original 1992 discovery, by New Horizons' 2 historic flybys, and by every GEO, round-based telescope scanning the outer dark since, is of a region far richer, far stranger, and far more dynamic than anyone imagined back when Pluto stood alone as the solar system's supposed 9th planet. The Kuiper Belt isn't a quiet, empty afterthought at the solar system's edge. It's a crowded, frozen, endlessly strange frontier, and humanity has only just begun to explore it.